Welcome, my students. We have already learnt about the Boyle's law. In Boyle's law, we get V proportional to 1 by P when P is constant. Now from this relation, we can write or V equal to K into 1 by P, where K is a constant of proportionality, or PV equal to K. That is, the product of pressure and volume is always constant for a given mass of gas at an unchanged temperature. From mathematics, we have already known that if two quantities are inversely constant, A proportional to 1 by B, that is A inversely proportional to B, or A equal to K into 1 by B, or AB equal to K. So keep in your mind for all the life that if two quantities are inversely proportional, then their product will always be constant. And we have already stated that if two quantities are directly proportional, then their ratio will be constant. This will be applicable for Charles' law. And here, the product of two quantities is directly proportional or constant, not directly proportional, constant for Boyle's law. So from Boyle's law, we have got PV equal to K, that is product of pressure and volume equal to constant. So if the initial pressure of a gas be P1 and under this pressure volume is V1 and final pressure is P2 and volume is V2 for a given mass of gas, then P1 V1 equal to P2 V2. And if the change pressure be P3 and volume V3, it will be P3 V3, change pressure be Pn and volume Vn, then it will be Pn Vn. So initial pressure into initial volume equal to final pressure into final volume. So among these four quantities, if we get 3, then the force can be known by applying this law P1 V1 equal to P2 V2. Now we will take a numerical from Boyle's law. Volume of a given mass of gas is 20 liters at 20 degrees Celsius under 5 Pascal pressure. Find the volume of that gas under 2 Pascal pressure at a temperature of 20 degrees Celsius. So this is the numerical. We have to solve this numerical. See that here temperature remains unchanged. That is, temperature is 20 degrees Celsius, initial temperature, and final temperature is also 20 degrees Celsius. And the initial pressure was 5 Pascal. This is 5 Pascal, initial pressure 5 Pascal. And final pressure 2 Pascal. And temperature initial was 20 degrees Celsius, final temperature 20 degrees Celsius, that is, temperature remains unchanged and the volume will be changed due to change of pressure. here the relation between volume and pressure will be applicable. So Boyle's law is applicable here. Now according to Boyle's law, according to this is solution. According to Boyle's law, we can write P1 V1 equal to P2 V2. Here P1, that is initial pressure, was 5 Pascal, 5 PA, and initial volume under 5 Pascal pressure was 20 liters. Final pressure P2 equal to 2 Pascal. Initial volume B2 equal to, what is the initial volume? Now according to Boyle's law, P1 V1 equal to P2 V2. Or here P1 5 into V1 20 equal to P2 2 into V2. Or V2 equal to 5 into 20 by 2. That is equal to 50. V2 equal to 50. So the final volume will be 50 liters. Let us see that pressure was 5 Pascal. Pressure was 5 Pascal. Volume was 20 liters. And pressure becomes 2 Pascal. That is 2/5. Volume becomes 50 Pascal. That is 5 by 2 times as the volume increased. So more the pressure, less the volume. Less the pressure, more the volume. This is Boyle's law. According to Boyle's law, final volume of the gas is 50 liters. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.